NASA is preparing to launch its next major Earth and climate science satellite. Welcome back to Techstination. I'm Fred Fishkin. Joining us is the Deputy Director of NASA Goddard's Earth Sciences Division, Tom Neumann. Hi, Tom.
Good morning. It's great to be here.
Great to see you. Nice to meet you. The Plankton Aerosol Cloud Ocean Ecosystem Satellite, mouthful there, known as PACE, that's a lot easier, is scheduled for liftoff tomorrow morning from Kennedy Space Center. This is a mission more than, 21 years in the making? Tell us more about it, Tom.
That's right. These missions don't come together just overnight. They begin with a science question or set of questions that we'd like to answer to better understand how the Earth works. Then we design instruments to take those measurements and then build, test, and assemble that equipment, and ultimately, if all goes well, launch it into space like PACE will be doing tomorrow.
You know, it's just amazing to me that technology changes so fast. So if you start planning for something like 2 decades ago, you don't even know what's going to be available in terms of the technology, right?
That's right. A lot of times we don't. So you have to make decisions about what kind of camera or what sort of sensor or what kind of hardware you're going to be flying many years before launch and operation of your instrument.
So what will this satellite be able to tell us that's really new?
So as the name suggests, or the long name, PACE has two main science objectives. Now, one of them is studying the ocean, and then specifically measuring ocean color. Ocean color really is as simple as it sounds. It's the color of the ocean. But those small gradations in ocean color tell us about what's living in the ocean. Things like plankton or phytoplankton that form the base of the food web and produce almost half of the oxygen here on Earth. PACE will let us monitor ocean health and those microscopic communities in the ocean in a way we've never been able to before.
Why should us everyday folks be interested, excited about this? What is it going to mean?
So the ocean data will help us do things like track and better predict harmful algal blooms that often close beaches when those algae communities, sort of explode and have high concentrations. But in addition, the other main objective of PACE is aerosols. That's the A in PACE, stands for aerosols. Now, those aerosols can be due to things like wildfire smoke or dust or sea salt or even human pollution. And those aerosols can be really harmful to folks when the concentrations get too high. I don't know if you had experience last summer of smoke from the Canadian wildfires, but down here in DC, we had a number of days with really poor air quality, and there were recommendations and alerts to avoid strenuous exercise outside, stay indoors, that sort of thing. PACE will help us track and better predict those as well.
And this will be working in conjunction with your other Earth observing satellites. Tell us how that will work.
So PACE is the newest member of our Earth observing satellite fleet. But as you know, we have a number of other missions currently on orbit. The Earth really is a system of systems. You can't really just look at the ocean without paying attention to what's going on in the atmosphere, or really understand land processes or ecology without understanding freshwater, atmosphere, ocean, temperature. It's all part of the puzzle. And PACE fills in a gap that we've had in our understanding by providing that better data on ocean color and changes in phytoplankton and other species living in the ocean, as well as how the atmosphere aerosol loading interacts and promotes things like cloud formation and precipitation.
Tell us about the types of technologies that you wound up using in PACE.
PACE is a collection of 3 instruments. Now, the main one is OCI, which stands for the Ocean Color Instrument. And that's that camera system that'll have 128 different wavelengths to measure really subtle differences in ocean color. Now, the other 2 instruments are what they call spectrometers, which are looking off axis at different angles than the OCI instrument. And that will complement the ocean color data by helping us to characterize the atmosphere.
Now, I know the launch is scheduled for about 1:30, 1:33 in the morning on a SpaceX Falcon 9 rocket. How long, assuming all goes well, and it will, how long before it's operational?
So you're right. Pace will launch at 1:33 a.m. tomorrow if all goes well. Right now, they're forecasting some potentially high winds that might push it by a day. But Pace will take off heading south, which is a little unusual for launches from Florida. Pace will separate from the rocket about 20 minutes or so after launch. And then they'll begin the process of turning on and checking out the spacecraft and the instruments. And we should start seeing data from Pace in about 6 weeks.
Takes about 6 weeks to get everything up and running the way you want it. And we should note that, like you said, there's always a chance when any kind of launch of a delay, but there will be live coverage. People can follow along if you're a night owl at space.com, right?
That's right. You can always keep up with us online at nasa.gov, or if you're interested in PACE in particular, that's simply nasa.gov/PACE, and you'll be able to find the live feed there as well as the playback if you're not a night owl up at 1:33 in the morning.
Well, congratulations on all of the innovations there and all of the work that went into this with you and the team there. Tom Neumann, thanks for spending time with us.
Thanks for having me.